All right, so I'm going to make one more video about those oblique asymptotes, just so you guys can see another example. So right away, I notice the degree is bigger on top than on bottom, and I think I'm going to have a hole there, so there's a lot going on here. All right, so first things first, let's factor it out. This divide out an x, factor out an x, I should say, x squared minus 9, and as we know, that factors into x plus 3, x minus 3, and then we've got x and an x plus 2. So again, immediately I notice that I'm going to have a hole here, and that hole will be at 0 because that will produce that 0 over 0 situation going on there. So replace x with 0, and then again, now that I've factored my, now that I've canceled my factors, I can substitute x with 0. Maybe some of you are already thinking about a situation that's going to happen. You'll see what happens. So 0 plus 3 is 3. 0 minus 3 is negative 3. 0 plus 2 is 2. 3 and negative 3 is negative 9. So negative 9 over 2 or negative 4.5, whatever you think. So I'm going to graph that right away somewhere down there. Okay. So then I'm going to erase this a little bit just to keep it simple. Vertical asymptote, there's one at x equals 2 or negative 2, sorry. X equals negative 2. Again, we're looking at the denominator. And then I'm going to do my x-intercept, so 3, 0 and negative 3, 0 from the numerator. And again, hopefully every time we do something, it's feeling like we know a little bit more. Okay, the y-intercept. So now we get to replace x with 0. Okay, so how do we do that? If we replace x with 0, we have the hole. So there is no y-intercept. The way that we get a y-intercept is we replace x with 0. But if you notice, we already did that and got this, and that's where our hole is. So remember, a hole is a mathematical impossibility. So if you have at this location something that should be happening, but it's actually this is priority. If this thing doesn't exist and says you're not allowed to put 0 in, you're only allowed to put 0 if we remove that factor, then that's what this is. There is no y-intercept. We just have this invisible dot where the y-intercept should be. In theory, this is where the y-intercept should be. That's the location of it. But it doesn't really truly exist there. And there's no other y-intercept. If I put a y-intercept up here, it would fail the vertical line test, right? So you can only have one y-intercept, and unfortunately, we're not allowed to plug 0 in because that came from the hole. Okay, end behavior. So now I've got, remember, I'm using this for my end behavior. And so if I'm going to do synthetic division, I'm going to divide by negative 2. That's my solution. But what we put here is the coefficients of this expanded. So it might actually be helpful if we thought about this. I move this down slightly. If we think about this as this, right? Because they're interchangeable. If I distribute these two back together, I do get x squared minus 9, and then I can use synthetic division with a negative 2 there because, again, that's the solution. If I write down the coefficients of the number on front, so 1x squared, no x's, and a negative 9, so x squared, there were no x's and negative 9, and then we'll do what we usually do. Bring down the 1. 1 times negative 2 is negative 2. Add these numbers together, multiply, add again, and there's nothing else to do in terms of synthetic division. We only had one solution there. This was an x squared, so this is an x number, no x's. So x's, no x's, remainder. The remainder, again, remember, is totally insignificant. So the end behavior equation is y equals x minus 2. X minus 2. So what I'm going to do there is graph -2. Maybe I should do that just a little bit. So up 1 over 1, up 1 over 1, just to kind of get a little bit of a gauge about how effective that line should be. And now I know exactly what to do because I can see the dots need to be connected. So it's very clear that like this dot and this dot needs to be connected. And remember, when I go through that dot, which I do because the multiplicity of the x-intercepts is odd, at odds we cross, so I have to cross through. Normally it plateaus this way. It's just going to plateau towards the curve and plateau towards the vertical asymptote here. So in an ideal world, this would be a much prettier graph. Thank you, Desmos, for being a prettier version of my artistic self. So on this way, it's going down. Multiplicity of the asymptote is odds. Odds face opposite directions. So if on this way it's facing down, on this way it must be facing up. I get to an intercept. I check the multiplicity of the intercept, which is odds. Odds we cross. Instead of plateauing this way, we're just plateauing this way. And look at me go. I've done it. Life is all good. This is so easy. I'm going to ace the test on Friday. Boom, nailed it.